Okay, so what I'm going to say off the top, you already know what verifying means, but I will at the top here, I put this in my notes to remind students. Verify with original equations. And the reason why I will ask you to verify your solution when you find it with the original equations that you're given. These are the original. Because when you rewrite them, you may make a mistake when you rewrite them and you try to graph them. If that happens to you, right? Let's say you make a mistake and you graph your lines and you're like, yeah, this is the solution right here. I'm going to use that, right? If you plug that in, if you plug those into the rewritten equations, it will in fact work out and you will think that's the solution to your system. But if you plug in the solution to these original equations here, it will not work out. Left-hand side will not equal to the right-hand side for one of them, or maybe even both if you made a mistake on rewriting both of them. And then you will know, okay, I made a mistake, right? I probably made a mistake, so I gotta redo, right? I gotta check what went wrong here. And so that's why I make sure you have that at the top of your page here. So how do I graph? We will read this first and then I'll explain how this works. Okay, solving the system of linear equations graphically. So we're going to do graphically, then we're going to do by substitution, and another method is going to be by elimination. So we're going to have three ways of solving a system. They all do the same thing, but one is often easier than the other. Okay. The solution to a linear system can be found by graphing both equations on the same grid. If the two lines intersect, the coordinates of the point of intersection are the solution of the linear system. So here, the coordinates of the point of intersection are the solution to the linear system. Okay. So you have options. We don't have room to talk about all of the options, but what I normally tend to do is I tend to rewrite my equations into slope-intercept form. Okay. I will do that here. Maybe rewrite equations into slope-intercept. Or I'll put a little or here. Determine slope and starting point. Chapter 6, right? We did that in chapter 6. If you just know a starting point and you use your slope to find other points, that's another way of graphing. There's nothing wrong with that. Okay, so I will call this equation 1 and I will call this equation 2 so we know which one is which. So we'll start with number 1 here. X minus y is equal to 5. I will bring the x over. So negative y is equal to, when the x crosses the equal sign, it turns negative. The 5 is already there. We're almost there. We're going to divide everything by negative 1. Y is equal to x minus 5. Okay. So from here, you know that start at 0, negative 5. And then we use our slope, which is 1. It's positive 1, so we expect it to go up. It's actually 1 over 1. Okay, so let's go ahead and graph that right away. So we start at 0, -5, and then we use a slope of 1 over 1, positive. So up 1 over 1 point, up 1 over 1 point. So at 3 points, that's good enough. Grab your ruler or straight edge. And the reason why I encourage 3 points is that it makes it more accurate right now, that it will matter where the line goes exactly. It's another reason why we do that. So you write down, you graph it, and maybe put the original equation, label it on one end like that. So you're done that. Okay, you've graphed the first one by rewriting it. Okay, the second one I will do here. 3x plus 2y is equal to 10. I'll bring the 3x over, so 2y is equal to negative 3x plus 10. You divide both sides by 2. Y is equal to negative 3 over 2x plus 5. This is slope in it, so start at, we're going to go 0, 5. And then the slope is negative 3 over 2, which tells us that the line is going to go downward. You're going to drop. Okay, so 0, 5 is up here, and let's follow our slope. Negative going to the top number, that's how I usually do it. That means that you're going to drop 3, 1, 2, 3. So your rise is downward 3 steps, over 2. So put a point down. Keep going one more time. 3, 2. And you happen to land right on. It won't always work that way. You actually end up landing right on the other line. And that is the other line, arrowheads, right? Make sure you have that and label it if you want full marks. And the POI, the point of intersection, is 4, -1. You make sure you label that on the graph, right? The point where they intersect on the graph. When you're solving graphically, it should be on there. So let's make an arrow there. And that's a very important point to us. So I'm going to use red to make it even darker. Not sure if you can see that. So we're almost done. Now we need to verify, right? It says verify, and you do that. So we're going to I'm going to just over here, going to go left-hand side, right-hand side. And I'm going to use the original, right? The x minus 5, y is equal to 5. And watch double negatives, okay? It's always there. X is 4, and then there's the minus of the actual equation, and then you go get your y, and y is -1, so make sure you put that in brackets like that, right? Because this really turns into a positive, so you have 5. Okay, and then you know that left-hand side is equal to right-hand side, so it checks out here. Okay, 5 is equal to 5. We can do the same thing here. If you run out of room, then just do it on loose leaf, keep going on loose leaf or something. Left-hand side, right-hand side. And I'm using the original, right? 3x plus 2y is equal to 10. And then I go 3x, which is 4, plus 2, and y is -1. That is 12 minus 2, which is 10. So really, oftentimes it'll be just on one side where most of the math actually happens. And so you also conclude that the left-hand side is equal to right-hand side. So now you state the solution is, so you actually confirmed that the solution is for -1. Right? So let's go back one bit. Mr. Dirksen, can you graph by finding both intercepts, like the x and the y intercept, and then coming up? Absolutely, you can still do that, right? If it's a slope point form, right, you take your point and then you use the slope to get more points. That still stays the same. Whatever you learned in chapter 6 is very much true still. So don't think that that's wrong. Okay. Next here, we have two equations again. I'm tempted to do that now, finding the intercepts. So I'm going to call this 1. I'm going to call this 2. Graph using intercepts. Just to add into the mix and so you don't forget that that can still be done. Okay? So x-intercept and y-intercept right next to one another. Okay? So I'm not rewriting it, I'm finding the intercepts. When you're trying to find the x-intercept, y is equal to 0, and here x is equal to 0. Okay? So the first one is actually fairly simple because, right, x plus 0 is equal to 8. X is just equal to 8, and it's 8, 0. Then you take the original equation again, but now x is equal to 0, so it's 0 plus y is equal to 8, which is really just y is equal to 8, which is 0, 8. Right? So we have that cleaned up, and no need to rewrite. You don't need to rewrite here because you have your intercepts. So let's go ahead and graph it. 0, 8, 8, 0, that's going to be a bit of a problem here. I see already. I had changed it on the original. I forgot to change it in your copy. Can we, sorry folks, we got to make a change here. I think if I go -2, I don't like it when this happens, but it happens. So we're going to change all the 8s with -2, okay? There we go. So fix that, 8 is gone, it's all -2. That way it works, right? It fits on our graph. So -2, 0 is right here, and 0, -2 is right there. Yes, you only have 2 points, and that's fine. Try to line it up. And there's your graph. And so it's x plus y is equal to -2. There you have it. And then for the second equation here, I'm actually going to stick to rewriting. So it's 3x minus 2y is equal to 14. You have -2y, and the 3x comes over subtracting. The 14 is already there. You just leave it. Divide everything by -2. Don't forget that the -2 applies to both. Okay, that's 3 over 2 positive minus 7. Which is a little bit of a problem, but we'll fix it. Okay, so what that means is we start at 0, -7, and then our slope is 3/2, which means because it's positive, it's going to go up, right? So we're going to just extend this y-axis a little bit and use that scale. Like this is 5, 6, 7, right about there. Just extend your y-axis a little bit, no problem, right? 0, -7 is right there. And then we're using a slope now to get us more points. So that is 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I'll do 3 points. Okay, and so that is 3x minus 2y is equal to 14. The POI, point of intersection, would be 2, -4. Right, 2, -4. Just make sure you label that. And then we're going to verify. I'll make a little note here. You could also graph by rewriting. Okay. And then we'll say that this in particular, if you look at the original equation here, it would have been y is equal to -x minus 2. Start at 0, -2, and the slope is -1/1, which would go down. So that still could have worked out for you. And look at it, right? 0, -2, we start there. Yeah, that's perfect. And then you would have dropped 1, ran 1, dropped 1, ran 1, right? Like you still would have come up with the exact same line. So don't forget that. It's still the same. So let's verify. Left-hand side, right-hand side. And I'm going to use the original, right? X plus y is equal to -2. And x is equal to 2, y is equal to -4. 2 minus 4 is really -2, so left-hand side is equal to right-hand side. Check here. I'm going to go up a little bit because I have that room. Original, right? 3x plus 2y is equal to 14. 3 times 2 plus 2 times -4. That would be 6 minus 8. Oh, something. Oh, yeah. Thank you, Loveleen. I made a mistake here. It's -2 there. That's why I was freezing. Thank you. There's my double negative, so that turns into +8, and that's 14. I was worried already. What? This is not going to work out? But it does. Thank you. Left-hand side is equal to right-hand side, and the solution is 2, -4. Within a context, like a word problem, this probably wouldn't work because, right, like cans and bottles, like you can't have -4 bottles, right? But if there's no context involved, then it is what it is, right? So let me just check here. I think what I'm going to ask you to do is complete this page here. So homework for 7.2, you do finish booklet. Right, you finish the booklet plus page 409. 3 to 5. Okay, let me just understand.